Being able to assign the null value to invoice count as an integer would be useful, but it's not possible. It's a value type. If the compiler can catch the problem, it'll complain. Otherwise, you'll get a runtime exception. For this reason, C# version 2.0, way back in 2.0, introduced nullable types, which use the nullable modifier, a question mark. To use a nullable type, you simply add a question mark to the end of the type name. And then the result is a type that has the full range of values of the base type plus the null value. So a 32-bit nullable int can contain whole numbers in the range of basically minus 2 gigabytes to positive 2 gigabytes plus the null value. A null Boolean can be true, false, or null, and so forth for all of the value types. Here's some code that shows how easy it is to use the nullable types. So the code here declares invoice count as a nullable integer, and it initializes it to the null value. Then it tests to see whether the value is null, and it's going to be in this case because there's no intervening code that changes the value. And then it writes something out to the console window depending upon the value of invoice count. Now you don't have to initialize the variable to null for a nullable type. You can initialize it to a non-null value and then later set it to null as well. And the default value of the nullable types is the same as the non-nullable counterpart. And so for invoice count, because its base type is int, the default value is 0. Okay, so that shows how easy it is to use. You just have to know when to use nullable types and not. But it's critical to understand that nullable types are distinctly different types from their non-nullable versions. So an int is not the same as a nullable int. So again, this is not an int value. It's a distinctly different type. So a double is not a nullable double, and so on. So here's some code that demonstrates that fact. So it starts by assigning a non-null value to invoice count. So at this point, invoice count is not a null. So what this does is it assigns a value that a non-nullable integer variable can contain. And then I'm going to uncomment this code. So now, if I move off there, you can see that I have a red squiggly. This error right here is just because I'm declaring that variable twice, so I'll comment out that line to get rid of that distraction. So here's the problem. So invoice count has a non-null value. I'm trying to assign it to a variable that is an integer, so it's the proper data type as far as the numbers go. But this is not the same as an integer value. And the message there says, cannot implicitly convert type nullable int to an int. An explicit conversion exists. Are you missing a cast? Okay, so these are not, you cannot do this because these are two distinctly different types. Okay, so let me comment out that line, return it. So what you need to do is cast it, or convert it, or use any of the other methods for converting data types. But the easiest way is to do a cast. Here I'm casting it to an int, and now I can store that value in old count. So this is another case where the compiler is being overly conservative because it's a narrowing conversion. So one would think that as long as this is not null, you'd be able to convert it to a null implicitly. But it's a narrowing conversion, but that doesn't work. And so the solution is just to explicitly cast it. And the compiler is quite content with the solution. There's no red squigglies here, and it works at runtime as well. Okay, but let's take this a step further. Let's now assign null back to invoice count. So we've used it here, we've done something with it, we want it to be null again. This is perfectly legitimate. Even though it had a value here, I can set it to null once again. Not a problem. The problem, though, is that this cast is now invalid. It's not possible to cast a null to an int, and so this is going to be a runtime exception. And I'll demonstrate that. I'll run the program. I'll select Q for nullable types. And there's the exception. And so what it's doing is it's taking that null value, you can see the value is null right there, trying to cast it, and it says nullable object must have a value. And the extension to that is it must have a value in order to do this kind of a conversion. Okay, so that's not going to work. And the specific exception that I got was the invalid operation exception. So I'm trying to do something that I can't do. All right, so now there are a few ways to handle the situation. For example, you could make old count a nullable int. So in that case, this would be a nullable int. It can accept a nullable int, and I can just directly assign a null value to it. I don't have to do any of these casts. Or you could test whether invoice count is null before making the assignment. And that's what this commented out line of code could do. So instead of this other statement that I'll talk about in a moment, I could just check to see if it's not null. If it's not null, then I can make the cast and the assignment, and then I'm good. Okay, but this isn't quite as clean because it really seems like it's complicating things, somewhat obviating the need for nullable types. But nullable types do have other features that help. And the biggest is that all of the nullable types have a has value property. This returns true if the variable contains a non-null value and false otherwise. And now you can write just code like this. If invoice count has value, you can and then you can execute that based on it having value. If it's null, then this line of code is not going to execute. Okay, so this really makes it easy to protect against runtime errors. But the bottom line here is that use either version of this that you think is better, clearer in your code, and so forth. All right, yet another nice feature of nullable types is the getValueOrDefault method. This method returns the value of the variable if it's not null, which is the get part of the name, or the get value part of the name, or the default value of the type if the value is null, which is the get default part of the name. Get value or default. I love it when Microsoft names things well. Okay, so now you can write code like this, and old count in this case, which remember is a non-nullable int, is either going to get the value, whatever the integer value is, or it's never going to get the null value. If the value is null, then it's going to return the default for an int, and so old count will be 0. And now in this case, I also no longer need to cast the return value because it's guaranteed to return a valid integer value. So very cool. Makes it very clean. All right, one other thing about all this is that you can't use the nullable modifier on a reference type because it's already nullable. So if I come to this code and remove the comments, whoops, hit the wrong key, and move off of it, notice that I have a problem, and it says the type string must be a non-nullable value type in order to use it as a parameter t in the generic type or method nullable t. Now, this is a bit of a confusing error message until you know that the underlying type for a nullable type in the .NET framework is system.nullable of t, where t is the appropriate type, like integer. So really the error message just means that you can't use question mark with that type. It's not a nullable type. Can't do it. Ain't going to happen. So I'll get rid of that comment again. Nullable types also have a value property that returns the non-null value if there is one, or raises an invalid operation exception if it's null. I really don't find that very useful in practical code, but feel free to use it if you find it useful. Okay, now, all of the operators that exist for non-nullable value types exist and are usable for the equivalent nullable type as well. The difference, though, is that if the nullable type contains a null, the result of the operation is going to be null as well, no matter what the other operand is. All right, so here's some code that shows that. So what this does is it defines three different nullable integers. X, which is initialized to 452, Y, which is initialized to null, and Z, which is initialized to 67. And then it performs various operations with those values. And so over here in the comments, I put what the result of the value is as each statement executes. So just so that you don't have to trust me, I'm going to set a breakpoint right there and run this code. I'll press R for nullable type operations. Okay, so all of this code is executed. And so now we can examine exactly what these values are. So first statement, I increment X. X is 452, so it becomes 453. Cool. That works perfectly. Everything is normal there. Now I'm going to do the same thing with Y, but Y is null. Remember that if I apply an operator to a null value, the resulting value is going to be null, so Y remains null. Null plus 1, in essence, remains null. Okay, then I take Z and initialize it to 67. I multiply X by Y times 14. Y is null, so Z is going to be null as a result here. I can then do Z here, X times X, 452 times 452. Now Z is non-null. And then I can take the product of X and Y, 452 times null. If there's a null value in this operation, then Z is again null. And so after all three of those statements execute, Z is null. So again, to emphasize the point, the important thing is that whenever an operand is null, the result of the expression is going to be null, unless you do something in the expression like the null coalescing operator or something else in order to change that value. Okay, so this characteristic of nullable types and operators can have some interesting effects. So consider this code here. So I'm doing a comparison. I'll get rid of the breakpoint there. So as this block of code starts to execute, X is still 453 and Y is still null. So let's go through this. And what are these different comparisons going to result in? Okay, so X greater than or equal to Y. Well, is X greater than or equal to Y? Well, X is 453, Y is null. Well, there's nothing inherent about a real positive integer number and nulls. Not that I've told you about it anyway yet. So then we compare it less than or equal, whether they're not equal, and then as a last step, set X equal to null and then do a comparison. Okay, so unless you've encountered this before, the answer is not going to be obvious. The general principle to understand is that when you do comparisons with nullable types, if the value of one operand is null and the other is not, all comparisons except for not equal to return false. And what's counterintuitive is that just because one comparison returns false doesn't mean that the opposite returns true. Okay, so I'm going to go ahead and run this code. I took out the breakpoint. I'm going to hit R again. And now you can see the results. So X is less than Y. And that result happens because I'm checking to see if X is greater than or equal to Y. That returns false, and so it executes this line of code here. So this is where you can get into trouble. If you just look at this, well, if this is false, then X must be less than Y. Well, no, Y is null, so that comparison always returns false. So you get misleading results. If X is less than or equal to Y, X is also greater than Y according to the results. So now we have a situation that should make your head explode. X is less than Y, X is greater than Y. Okay, We're dealing with integers. There's no fancy highfalutin numbering systems going on, or imaginary numbers, or things like that, or quantum physics going on. This can't be the case. But you have to understand that that comparison is always going to return false if one of the parameters is null. Okay, and then coming back down here, scroll down so you can see the rest of the code for the rest of the operations. So we're testing here, x is not equal to y. Remember that I said that this is the one comparison operator that does work. X is an integer number, y is null, they're not equal, so this in fact executes. The result here is true. Okay, and then the last example here is where I set x equal to null, and I'm checking whether or not they're equivalent. Now both of them are null, and this comparison works. So again, if x was still a positive number, or an integer value of any negative or positive or 0, then it would return false, but in this case both of them are null, and so x is in fact equal to y. Okay, but again, emphasize, I changed the value of x for this last example. Okay, then I also want to talk a little bit about nullable booleans. Nullable booleans follow the same rules as other nullable data types with respect to comparison operators. So this is just some code that drives that point home. It declares two nullable bool variables and then tests every combination of true, false, and null values. So it sets x to true, y to true, and then it does these different operations on them. It displays x and y. It does an and, does an or. And so all of the right line statements are the same. But then I'm setting y to false. I'm setting x to false, y to true. So all the different combinations of true, false, and null. So down here I start to get into setting the different values to null, ending in both of them being null. So I'll execute this code. And this time execute S for nullable booleans. And there's the table. Now, remember that a null value isn't displayable within the console window unless I convert it to a string somehow. So all of these values here are null values. So you can go through the line. When x is true and y is true, x and y is true, x or y is true. Okay? True and false, x and y, that's now false, this is now true. And you can go through. So what's interesting is we get down here to the nulls. So x is true, y is null, x and y is null, x or y, in this case one of them is true, and so it returns a true value. So keep in mind, these are logical operators, they're not comparison operators. Comparison operators return a false if one of the operands is null. These are logical operators, different thing. Okay, so here I have false and y is still null. So x and y is now false because they are not both true. And x or y is now null. All right, and then basically the same sort of things for x being null and y being true or false, and then x and y as well.